Hey guys, okay, so these are the last three problems. So number 5, I just wrote down what I know right here. I know that the initial velocity is 1.1 meters per second because remember all of these problems are related to one another, and it said the initial velocity was 1.1 meter per second. And then we found the final velocity to be 0.8 meters per second. So we get the initial from question 3. We get the final from question 4. So initial is 1.1 meters per second. Final is 0.8 meters per second. I just want you to remember where I got those from when we're doing number 5. So I wrote them right here. Number 5 says, now that I know the velocity at the end of the ramp, that's my final velocity, and that's my initial velocity, and the velocity at 100 centimeters, here's my 0.8 meters per second, that's the final. So we're going to say this is VI, so it's equal to 1.1. Velocity at 100 centimeters is our VF. So remember, here we had a ramp. Here's our VI. Here's our VF. And we'll say that's 100 centimeters at 100 centimeters. And we got that again from the previous question. Photogate captured the speed of the ball at 100 centimeters. Okay. What is the acceleration of the ball on the floor if it took 1.3 seconds to travel? So from here to here, it's telling me it took 1.3 seconds to travel. Okay. What is the acceleration? I want to know what is the acceleration from the initial velocity to the final velocity if it took 1.3 seconds. Well, we happen to know a formula for that, right? So we know that acceleration is equal to the final velocity minus the initial velocity over the change in time. So because we know all of these pieces, it's very straightforward. We know these pieces because this is a cumulative problem that we're working on. So final velocity was 0.8 meters per second. Okay. Minus the initial was 1.1 meters per second. And remember, with acceleration, it is okay to have negative. That means we're decelerating, right? So then the change in time was 1.3 seconds. We got that right here. So if I use my calculator, and again, you should be doing this ahead of me and coming back if you need help. If I use my calculator and I calculate all of this out, I should get my acceleration to equal a negative 0.231 meters per second squared. Okay. Charlie, you need to leave the room, please. Shut the door, please. All right, and we know it's meters per second squared because we have 1 over 1 second and we have 1 here. So it's meters per second squared on the bottom. So this is our acceleration from the initial velocity to the final velocity. Keep that in mind as we continue working down the problems. All right, so number 6 says, pause, please try to do number 6 and then start this back up if you need help. Number 6 says, we can assume that this acceleration is constant for the whole floor. So it's decelerating at a rate of 0.231 meters per second squared. Therefore, the ball will experience this acceleration up until it stops. So it's slowing down is what it's telling us at this rate until it stops for good. And we want to know how long is it going to take until it stops for good. Okay. Well, again, we know the equation for acceleration. We don't know at this point the time. That's what we're looking for. How long would it take? Okay, we do know the acceleration. The acceleration we just found right there. Okay, we know the final velocity from a problem before. We know the initial velocity because it told us in an earlier problem. So what we have to do here then is isolate the variable. Okay, so go ahead and try to work this out so you get the variable isolated. Okay, so pause. And what you'll end up finding is, okay, so if you did that and we're trying to isolate, you know that we would multiply this t up. So it'd be t times a, be the change in t times a is equal to VF minus VI. We still need to get t by itself, so that means that we have to divide a back down. So then we know that the change in time, because that's what we're after, how long, is equal to the final velocity minus the initial velocity divided by the acceleration. Okay, and then when I plug that in, I know that my final velocity was 0.8 meters per second, crazy mountain M, minus the initial velocity was 1.1 meters per second. My acceleration, I know, is that negative 231. Okay. Or excuse me, 0.231. I don't know why I want to keep moving that decimal, but I don't. 0.231 meters per second squared. Okay, so I have one S, another S, another S, 1 meter, 1 meter, another meter, so I'm left with seconds. Okay, and that, if I calculate that out, is going to give me 4.76 seconds, if I did my math correctly. Seconds is a unit for time, so we should be good to go there. All right, and again, I hope that you are pausing and returning to this as needed. All right, so let's try number 7. And I just wrote this down here for time's sake, but this is information that I have from the other problems and from what number 7 gives me. So please try to do that on your own, and then pause and play as needed. Okay, so 7 says, let's say we want to know how fast the ball was moving on the ground after 2 seconds. Okay, so it took from here to here to go 1.3 seconds, so another 0.7 seconds would be 2 full seconds. So I want to know how fast the ball was moving at that point. Okay, so my time is going to be 2 seconds. Okay, here's my time. It's going to be 2 seconds. The reason I know it's 2 seconds is because my problem tells me I want to know how fast the ball is moving after 2 seconds. Using the initial velocity, which we know was 1.1 meters per second because we found it previously from the question before, and the acceleration of the floor, remember we know the acceleration of the floor is negative 0.231 meters per second squared. We found that in number 5. How fast would the ball be traveling? Okay. So again, we are going to have to isolate a variable. So we know that acceleration is equal to VF minus VI, and we want to know VF in this case because it says how fast. Okay, VF minus VI over the change in time. We have all the other variables. Acceleration, negative 2.31 meters per second squared, check. VI, 1.1 meters per second squared, check. Change in time, 2 seconds, check. So what we're trying to find is that final velocity. So we have to do some isolating of the variable, right? So we can do that. Go ahead, pause, and try to do it on your own. So again, what I need to do is I'm going to take this t, I'm going to move it up. So VF minus VI is equal to acceleration times the change in time. And just to make things clearer, I'm going to put this in parentheses, okay? Because I still need to get VF by itself. And how do I do that? Well, it's minus VI, and I need to get VI on this side, so all I have to do is add it over, right? So then my equation, when I'm trying to just find the final velocity, is going to be VF is equal to acceleration times change in time. Okay. Watch, the units will work out too. Plus the initial velocity. Okay, so let's go ahead. We'll plug that in. So the acceleration was negative 2.31. Negative is just telling me that it's slowing down, okay? So you don't have to worry about that negative so much. Meters per second squared times the change in time is going to be that 2 seconds. Okay. And we're going to put parentheses around that. Now, this is on the top, this is on the bottom, so we get to cross out one of those seconds. So now I shouldn't have just crossed, it's still seconds on the bottom. Okay, meters per second, right? And then I do plus my initial velocity. My initial velocity is 1.1 meters per second. Okay, and again, I get to cross those out, so I'm left with seconds. Okay, meters per second, I should say. Okay, so my final velocity, if I calculate this out correctly, should be a negative, after 2 seconds, should be a negative 0.638. And it's velocity, so I know it's meters per second. Okay, so what I did is I multiplied this out and then added this in, and I get a negative 0.638 meters per second. So hopefully that's helpful where you guys are at, and hopefully with a little review tomorrow we will be ready for our test. If you'd like to make a one-sided note card with some of these equations, acceleration, velocity, if you want to do kind of some of the math to map out to isolate some of those variables, you're welcome to do that, but you can only use one side, all right? I will see you tomorrow, and good luck.